Okay, so if once you have written the equations in reduced form, then it can actually be estimated using the OLS method, because you don't have the simultaneity problem anymore. Okay, so if you do that, you will get unbiased and consistent estimates of the reduced form parameters, because as we said before, there is no problem of simultaneity. However, what we are interested, all right, is not on estimating or finding good estimates of the reduced form parameters. We want to find estimates of the structural parameters and good estimates of the structural parameters. So the question is, can we find, all right, the estimates of the structural parameters from the estimates of the reduced form parameters? Okay, that's the first question. And if we can, how do we go about doing it? Okay, so we can only do this, all right, for the first question. We can only do this if the equation, all right, remember your simultaneous equation model has many equations, all right, so you have to go through equation by equation, and if a particular equation is identified, then it is possible. If the equation is not identified, then it is not possible. What do we mean by an equation identified or not identified? Okay, so we now want to talk about the problem of identification. The number of reduced form parameters must be more or equal to the number of structural parameters. Okay, so if this is true, then you don't have a problem of identification, right, for that particular equation. If this is not true, then you will have a problem of identification, because the equation will be under-identified or unidentified. Okay, why do we use this term identification? Because we don't know, how, whether that equation can be identified or not separately from some other equations. Okay, so for structural equation, all right, in your simultaneous equation model, again, simultaneous equation model consists of many equations. So we're going to look at equation by equation, all right? So if you have your structural equation in your structural model, it is unidentified. If it is unidentified, then it cannot be estimated. If it is exactly identified, then you can get unique estimated values, okay, for the parameters of the equation. If it is over-identified, okay, technically you can actually have more than one estimated value for the parameters of the equation. You can think of, in terms of, if you have in your math, when you do simultaneous equation model, or if you have a simultaneous equation, you want to solve for the variables, right? If you have 3 variables, then you actually need 3 independent equations, right, to solve, to get unique solutions for your variables. If you have 3 variables, but you only have 2 equations, then you cannot solve, you cannot find unique solutions for your variables. Okay, similarly, if you have more than 3 equations and you have 3 variables to solve, then technically you can actually have more than one value for each of variables. So the same thing when we talk about simultaneous equation model. So what would be the conditions for identification to determine whether a particular equation is identified or not? Okay, you have 2 conditions. One is what we call the order condition. This is your necessary condition. And the other one is your rank condition. This is your sufficient condition. In this lecture, I'm just going to focus on the order condition. Usually when the order condition is fulfilled, then the rank condition would be fulfilled. But you also need to check for the rank condition. I will leave it to you to do the reading on the rank condition. For the order condition, all right, if for each equation that we're going to look at, we have to make sure that the number of excluded predetermined variables has to be greater or equal to the number of included endogenous variables minus 1. Okay? So if we have this part over here, we call it A, the number of excluded variables. And if we have on this part here, we call it B, the number of included endogenous variables minus 1. Then if A, this part here, is less than this one, okay, then your equation would be under-identified or unidentified. If you have A is exactly equals to B, the number of excluded predetermined variables is exactly equal to the number of included endogenous minus 1, then your equation is what we call exactly identified. If your A is greater than B, then that equation is over-identified. Okay, so the example that we had earlier, for instance, for your market equilibrium model, okay, we have two equations that we're interested to estimate. This equation, your demand equation, as well as your supply equation. We're not going to estimate this one. This is just your equilibrium condition. So we want to know whether are we able to estimate this equation or not, and are we able to estimate this equation or not. Okay, so we have to check for the identification conditions, right? So over here, as what we said before, our endogenous variables would be your QD, QS, as well as P. And the predetermined variables in this case is Y. Okay, so we want to check whether, all right, A is less than B, or A is equal to B, or A is greater than B. So if we look at this equation, we have two, all right, endogenous variables. So two endogenous variables, which is included in this equation. So minus 1 is equal to 1. So B here is equal to 1. All right. Now, the number of excluded predetermined, the predetermined variable is Y. We don't have anything which is excluded because Y is the only one. Therefore, A is equal to 0. Right? So if A is equal to 0 for this equation and B is equal to 1, right? Then we have this condition of under-identified or unidentified. If we look at this one, okay, therefore this equation is unidentified. Now if you look at the supply equation, okay, we have QS and P. These are the endogenous variables that are included. Therefore, B would be equal to 2 minus 1. So this is going to be, B is 1. The number of excluded predetermined variables, here the predetermined variable is Y and is not in this equation. So the number of excluded predetermined is 1. So A is equal to 1 and B is equal to 1. So we have this condition A equals to B. So for the supply equation, all right, this is exactly identified. So another example, right, the labor market of merit housing, merit working women, all right, we have the two equations, hours as well as log of wage, and hours is dependent on the number of hours worked in the year, depends on what is the estimated wage, depends on education, depends on the age, depends on number of kids less than 6 years old, and depends on the non-wage income, all right, which is defined to be the total income minus own income. Okay, and the experience would be the actual labor market experience. So when we have this model, all right, which consists of two equations, the endogenous variables will be the hours work as well as the wage, right? And the rest of them would be your predetermined variables. Okay, so we have two endogenous variables, and we have uh, 1, 2, 3, 4, 5, 6, 6 predetermined variables. So we want to know for this equation whether this equation is identified or not, and for this equation as well whether it is identified or not. Okay, so let's focus on the first equation first. For the first equation, the number of excluded predetermined, we have included education, age, kids, and non-wage income. All right, these are the predetermined variables that are included. The one that would be excluded will be, in this case, experience and experience squared. So the number of excluded predetermined will be 2. Okay, the number of included endogenous, we have two endogenous variables, hours and log of wage. All right, we have both, and minus 1, therefore it will be 1. So over here you have 2, which is greater than 1. Therefore, in this case, this equation here would be over-identified, right? For the second one, you can go through the same thing. We have actually 3 excluded predetermined variables, and we have 1 for the number of included endogenous minus 1. So in equation 2 also, this equation is identified. In fact, it is over-identified. Okay?